Right. Good evening, my dear learners. Welcome to our third lesson for Technical Sciences, grade 12. And we are continuing with Newton's laws of motion. And in particular, we in the past lessons, we looked at Newton's first law of motion, and we really dig deeper into it. And then we looked at Newton's second law of motion, on Monday, as well as yesterday. But yesterday we were focusing on one body system, and that is where we were actually applying Newton's second law equation. So today, I want us to actually look into two body systems, because with two body systems, there are quite a number of questions that they can ask you, and we must be able to work with that. And when we are done with that, we are going to then look at Newton's third law of motion. In other words, tomorrow's lesson will be the last lesson on Newton's laws of motion, and we'll be doing questions holistically that encompasses Newton's first law up until Newton's third law of motion. For today, we are going to look directly into one question on two body systems, on two objects, which forms a two-body system. And we are going to look at some of the questions that they can actually ask us, and how we are going to mark you during the course of the year in your trial examination, as well as in the final examination. So please let us take heed of that. So I'm going to share my screen now, and we are starting with our lesson. Right. So basically what we have on here is our question paper, and this question paper is from the Free State, and it's a paper from the trial examination in 2018. And I can promise you, my dear learners, if you are able to answer these questions, then I can also promise you that you are well on your way to performing well in this particular topic. So let us get started. We are going to look at question number 2 from Free State, September 2018. And this is how the question reads. It reads as follows. Tom applies a force of 30 newtons on a crate. We rate the crate over a frictionless horizontal plane as indicated in the diagram below. Now, when we read here, we need to take into account that there are some words in science, and particularly in technical science, that give a force that is being applied, and it has a magnitude of 30 newtons. So that is the applied force, right? So this symbolizes F applied. And then on a crate with a mass of 50 kilograms, and they tell us that it accelerates. Now, if it accelerates, then we know that the net force is greater than 0 newtons. So there is a net force, because an object cannot move, rather cannot accelerate without a net force. And they are telling us that it moves over a frictionless horizontal surface. In other words, the surface is smooth, and therefore there is no frictional force. So that tells us the frictional force is definitely equal to 0 newtons. It's not there, as indicated in the diagram below. Now, in the first question, we are asked to define the term acceleration. So there, before we start, here we have an object, and that force that is being applied of magnitude 30 newtons, we know very well that it represents the force that has been applied. So we are required to then define the term acceleration. Now, we know by now that when we talk about acceleration, we are talking about the rate of change of velocity. The rate of change of velocity. And that definition is not part marking, so it's 2 or 0. In other words, if you omit any word there, that gives us meaning, then you are going to forfeit your marks because now the definition will be incorrect. So when you go to your examination guidelines, you will see that the definition for acceleration is stated as written here. And that is why I always emphasize to you that we will only accept definitions and principles that are found in your examination guidelines. And rate there is a keyword because when you talk about acceleration, we are basically talking about how fast your velocity is changing, right? The velocity of an object is changing. That is why we talk about the rate of change of velocity. So if you omit the word change there, it will also be incorrect. And why is it incorrect? Because it is not the rate of velocity. It is the rate of change of velocity. And hence, if there is no change in velocity, in other words, if your velocity is constant, if your velocity remains the same for a certain period of time, then you don't have an acceleration. Why? Because there is no change of velocity. And hence, when we talk about acceleration, we are talking about the rate of change of velocity. Right, my dear learners, I hope you have that. Right, then let us go to 2.1.2. Now, 2.1.2, they ask us, we must calculate the magnitude of the acceleration of the crate. In other words, we want the magnitude, we want the size of the acceleration, we want the value of the acceleration. But here, my dear learners, because they said magnitude, it means even if right, my dear learners, I hope we are still together. There was just a technical glitch there. So we are back, right? So we were required to calculate the magnitude of the acceleration of the crate. So I was telling you that to calculate the magnitude of the acceleration of the crate, we can use two formulas. Now, in these formulas that we can use, we then check, okay, if I want to calculate the acceleration, do I know the mass of the object? Yes, I know the mass of the object because they told me it's 50 kilograms and it is also indicated there. Do I have the net force acting on an object? yes, we have the net force acting on an object. We can actually just show how we get there. Or we could use this formula. Acceleration is equal to delta V divided by delta T. Now, if we wanted to use this formula, it means we must know the final velocity of the object and the initial velocity of the object. And we must know the time it took for that velocity of the object to change, right? Now, if you look at the question, you can definitely see that you were not given the velocity of the object when it moved from one point to another. And you also don't know the time it taken for the duration of the motion when it moved from one point to another. As a result, this formula does not become relevant, and this one formula will become relevant. Now, before we do our calculation, let us just do something there that we call a free body diagram. Let us talk about a free body diagram. Now, remember to calculate the net force. The net force is that single force that has the same effect as all the forces acting together on an object, right? And therefore, to calculate the net force, we'll remember that we take the sum of all the forces that are acting on the object, and we actually take the vector sum because we need to take direction into consideration. So if we look at this object and we try to do a free body diagram, remember our free body diagram, we represent the object with a dot. And we know all objects are attracted towards the center of the earth, and that is through the force of gravity. Now, another force that is acting here, we can see that the object is on a surface. So there is a force that the surface exerts on the object, and it acts perpendicular to the surface. And we know the name of that force is the normal force. Another force that is acting here is the force that is acting to the right, and we call that force the applied force. Now, the object is not experiencing any friction. Why? Because they told us there that the horizontal plane, this horizontal plane is frictionless. So there is no friction. It is frictionless. So it means these are all the forces that are acting together on an object. So remember, we wanted to determine the acceleration, and we wanted to use this equation F net is equal to ma. This is what we are looking for, the mass we have, so we want the F net. Now, when I want to calculate the F net, these two forces are balanced vertically. In other words, vertically, I have a net force of 0. Why? Because my object is not going up and down. This object is not going up and down. So it's only moving horizontally. So if it's not going up and down, it means there is no vertical motion, and therefore there is no net force, or rather the net force vertically is 0. So we look at the net force horizontally, because the net force horizontal is the one that is for the acceleration. And the other way, is no force that you would have made sure that you draw your object there, then you show the force of gravity, the force acting downward, you make an arrowhead, right at the tip, and you make sure that your arrow is touching the dot and you are giving the correct label for the force of gravity, and that would apply to all the forces. Then from there, remember now, we are continuing with our question. So we want the acceleration of this crate. So the net force, we have correctly determined that it is 30 newtons. Now there, I need to show my direction, and we can say the right must be positive and the left must be negative. Now, because that applied force is 30 newtons and is 30 newtons to the right, it means I'm substituting my value as a 30 newtons, which is positive because it is to the right, and we said to the right must be positive. And that will be equal to the mass of the object. We can definitely see that it gives us 15. And we are looking for the acceleration. And for the acceleration, because I don't know it, I will multiply that by 8. Then to get my acceleration, I am going to say, for the acceleration, I will divide both sides by 50. If I divide this side by 50, I must also divide that side by 50, because what we do on the left, we must also do on the right. In other words, my dear learners, this is what I'm basically saying to you. If I have 30 is equal to 50A, the 50 divides the 50, you are left with A. Then the answer there will be equal to 30 divided by 50. So my acceleration there is going to be equal to 30, and I'm going to divide that by 50, and that will give me 0.6. And remember, it's acceleration, so the units are meters per second squared. And remember here, our question said it only wanted the magnitude, so we don't have to give the direction. It only wanted the magnitude. So how will we mark this one? The first mark is for the correct formula that you get from your formula sheet. The next mark, the entire substitution, right? The last mark, because it was marks, it is going to be for the acceleration. But remember, you have to put your, if you don't put a unit, then that answer is not going to get a mark altogether, and that unit must be correct. And remember, it's meters per second squared, so there it must be m dot s to the -2, because I've seen some people, they will do this, meters second exponent -2. This is entirely correct. There must be a dot. Rather, this is entirely wrong. So the correct one is that there we must have a dot. Right, my dear learners, let us move to the third question. Consider the situation creates here of masses 10 kilogram and 115 kilogram are connected with an inelastic rope of negligible mass. So already, if you look at the diagram, there you have those two crates. They have a mass of 10 kilogram and a mass of 115 kilograms. And these objects, my dear learners, we can see that they are connected by that inelastic rope. It means there is the rope. And they are saying we can actually neglect the mass of the rope as shown in the diagram below. A horizontal force of 500 newtons is applied as shown. So if we read that statement, we go and we check as shown. So that 115 kilogram mass that applied force of 500 newtons. The applied force is only acting on the 115 kilogram object. It is not acting on the 10 kilogram object, even though they are one system, even though they are connected together. So it is only acting on that object. Then tell us the two. In other words, there is a net force. So the net force will be greater than 0 newtons, because Newton's second law of motion tells us a net force acts on an object, the operate in the direction of the net force. So when we accelerate, it means there is a net force because the object will be accelerating in the direction of the net force. Then they ask, frictional forces of 300 newtons and 150 newtons act on the 115 kilogram and the 10 kilogram crate respectively. Now, that should be very clear because they are telling us it's a frictional force of 300, then that of 150, and it acts on 150 and 10 kilogram respectively. Respectively means in that order. In other words, the 300 newtons is acting on the 115 kilograms, and the 150 newtons frictional force is acting on the 10 kilogram object. And what is that on the 10 block, they've indicated to you there that that force is 150 newtons. And you know, Fk is a symbol for kinetic friction, the friction that the object experiences when it is moving. Remember, when the object is not moving and there is a frictional force, that frictional force, we call it static friction. Now, there we have kinetic friction. In other words, the frictional force that is acting on the 300 kilogram block, rather on the 115 kilogram block, will have a magnitude of 300 newtons. Now, my dear learners, from this information and this diagram, what you can see is that they are showing you the frictional force on the 10 kilogram object is going to the left, right? In other words, it tells me the direction of motion. This 2 is definitely to the right. How do we know it is to the right? Because the frictional force is a force that opposes direction of motion of object, and it acts parallel to the surface. So it is opposing the direction of motion of an object. In other words, the direction of motion of an object must be to the right. Now, what does this mean as well? If you analyze the diagram, there is a connection there between the 10 kilogram block and the 115 kilogram block. Now, if this object is moving to the right, obviously, the acceleration of this 2 is going to be the same. Why is the acceleration of both of them going to be the same? Because they are one system. Yes, it's two objects, but because they are connected, they are one system, so they move together. So if they move together, it means their acceleration is going to be the same. So the acceleration on the 115 kilogram block is the same as the acceleration on the 10 kilogram block. Are we together? Now, we know as well from term 1 that when I have two objects connected by string, there is going to be tension that is created in the string, right? Or rather, there they tell us on the rope. And the tension, we always do it like this. Just do this. On the 110 kilogram, it will go that way. On the 115 kilogram, it will go that way. So it will go in two different directions. What you need to do is just here, okay, I will redraw the string. And there you have your 10 kg and there you have your 115 kg. All you have to do is to make two arrows to face each other, can face each other, is if you do it this way. So the two arrows are facing each other. So that already tells you the tension on the rope. The one on the 10 kilogram is the tension that is acting to the right. The one on the 150 kilogram, 115 kilogram is the one that is acting to the left. So there, our tension is the same, obviously, on the 10 kilogram, and it is the same in magnitude on the 115 kilogram. Is just that the two tensions will act in different directions. Now, what is wrong? Obviously, if this is your 10 kilogram and this is your 115, you can't do this. Why? The arrows are not facing each other, so that is incorrect. The two arrowheads must face each other, and that will always give you the correct direction of the tension. Right, so that is just analyzing of the diagram. Now we are required to draw a free body diagram of all the forces acting on the 115 kilogram crate. Now, this is the 115 kilogram crate. So the question is 2.2.1. Now, here what you will see is that it's a free body diagram, so we make our dot, right? I prefer to make my dot big. Then, and nicely round. The first force is the force that acts on all objects, which is the force of gravity. And remember, it goes downwards. And then we have the normal force. Remember, it's one mark here because it is touching, it has an arrowhead and the correct label. It is touching the dot, it has an arrowhead and a label. And the same applies to all of them. So this one will be the applied force. Remember, this is the 115 kilograms, so it has that applied force of 500 newtons. Then again, we can see that we have tension. How did we determine it? It's that one, the one that is on the rope, this one. And the last force that we have, remember, they said there is that frictional force of 300 newtons. And because the object is moving, then we talk about kinetic friction. And that will give us 300 newtons. So that is Fk. Right, so when you label it, you actually don't have to include the magnitude. You must just give us the correct label of the force. So that will be Fk. So that will be 1, 2, 3, 4, 5 marks. There we go. So that will be our free body diagram. Remember, it must be straight. Number 2, it must touch the dot. And it must have an arrowhead as well as the correct label. So that is where our 5 marks comes from. Then we have 2.2.2, and they say we must state Newton's second law of motion in weights. And if you check there, we have allocated how many marks? 3 marks. So to state Newton's second law of motion, you will say when a net force acts on an object, right? There is a net force. Remember, it acts on the object, right? So what happens when the net force acts on the object? The object will accelerate, the object will accelerate in the direction of the net force. So that will give us the first mark. Then you have given us that now there is a net force acting on an object, so it causes the object to accelerate in the direction of the net force. Remember, for the first part, that net is compulsory, so it will give you 1 mark. Then we go. Remember, after that, you must give us the relationship between acceleration and net force. So we will say acceleration is directly proportional to the net force. So that carries a mark because you gave us the relationship between acceleration and net force. And you will say, and it is inversely proportional to the mass. And the mass is obviously now the mass of the object, right? And that will give you the 3rd mark. Are we together, my dear learners? So that is essentially how you will get your 3 marks. Then the next question says we must calculate the acceleration of the system. So we are required to calculate the acceleration of the system. Now, what you need to realize here is that they did not say they want the magnitude of the acceleration. So it means now we also have to give direction. So if they want the magnitude, they will specify to you. But if they just say the acceleration of the system, it means you need to give us both the magnitude and the direction. Why? Because acceleration is a vector quantity. And what do we say? A vector quantity is a physical quantity that has both magnitude and direction. So we want acceleration, you gave us both magnitude and direction. But if I said the magnitude of the acceleration, just like in this question, then you would have just given me magnitude without direction. But there I want the acceleration, so you will give me both the magnitude and the direction. Now, remember how we calculate acceleration. We have 2 formulas. We can use that one where we say A is equal to delta V divided by delta T. But for now, this one is not relevant. And why is it not relevant? Because we don't have the time that the object moved and how the velocity of the object moved. But it's still a formula for acceleration. So what must we do now? We must explore another formula that has acceleration. And that formula is Newton's second law of motion formula, where we say F net is equal to ma. Are we together? Now we are dealing with 2 objects here. So it means if we are dealing with 2 objects, then we need to deal with each object separately. Now, when we deal with each object separately, we will be able to get all the 7 marks. But if you use a system, the system method, where you combine the mass of the object of the system and so on, you will be penalized, and we don't accept it. And that is why when you have 2 objects and it's a 2-body system, you deal with each object separately, right? Then let us start with the first object. Let us deal with the 115 kilogram object. Now, if we deal with the 115 kilogram object, remember we drew the free body diagram for the 115 kilogram object, and it was this one altogether. And we are saying for the net force, this force and that force, they balance each other. They have the same magnitude. This and this magnitude is the same, but it's acting in opposite directions altogether. Now, if it acts in opposite direction and the magnitude is the same, it means the net vertical force is going to be 0. But these forces are not balanced, and hence I have a net force, and hence the object is accelerating. So these are the forces: the tension, the kinetic friction, and the applied force are the forces that are responsible for the acceleration of the object altogether. So we are not going to include these two because the net force in the vertical direction is 0. So it means that will be F applied. Remember, a short symbol for F applied is F capital letter A plus the kinetic friction plus the tension is equal to MA. Right? It's these three forces that we are talking about. Now, I add them because the net force wants you to do that vector sum of all the forces acting on an object. Now, let us choose our direction. Let us say to the right is positive and to the left is negative. Then we check if we have the magnitude of the applied force. And yes, we do. It was given from the onset, and its magnitude is 500 newtons. And it's acting to the right, and therefore I will substitute the value as positive, which is 500. Remember, it's a vector. We are going to substitute it with direction plus the kinetic friction. So plus there means I am adding the forces. Now, the frictional force acting on here, we know on the 115 kilogram, it is 300 newtons. So, but it is acting to the left because we already saw that from the direction of friction that was given on the 10 kilogram block. It was to the left. In other words, the motion, the direction of motion was to the right. You see, there's the friction. Right, but on the 3 kilogram block, obviously it is acting somewhere there, right? So it will be plus, rather on the 115 kilogram block, it's also acting in to the left, and that will be plus negative 300. Remember, the plus is just for saying we are adding, and the negative is the direction of the force. Plus the tension. Now the tension here, you saw it is acting to the left. It is acting to the left. And we drew a free body diagram as well, and we saw that it's acting to the left. Now, I want to make this one clear. Remember, you are actually trying to solve for acceleration. You are not trying to solve for tension. And therefore, yes, we understand you do not know the value of the tension, but you put it there as a substitution because you are not solving for it. So we substitute tension, and we'll substitute it as negative tension because on the 115 kilogram block, it's acting to the right. Excuse me, it is acting to the left, and that is why it is negative. And this will be equal to the mass of our object. And the mass here, we are dealing with the 115 kilogram. It will be 115 multiplied by A. Remember, mass is a scalar. It doesn't have direction. So my dear learners, there you give it direction because you are not solving for tension. So it's as if you are, in fact, you are substituting the tension, and it is acting to the left. It's just that you don't have the value, and hence you substitute it as T. Then To solve for that, if you do your maths, 500 plus positive times negative, it's negative. So 500 minus 300 will give you 200. I'm adding this because they are constants, right? They are values, they are the same. And then positive times negative, it's negative t, and that will give me 115A. If I take the tension to the right, the tension will now be positive. And on the left, I'll still be left with the 200. If I bring the 115A this side, it will become negative. So it will be minus 115A. Then we can see there are two variables that I do not know. So automatically it tells me that because we apply mathematics as well, I need to get the second equation that has acceleration and tension so that I can solve simultaneously. So we go to the 10 kilogram block. Now, when we look at our 10 kilogram block, we will apply the same equation and say F net is equal to MA. Now, when we look at the 10 kilogram block, remember now, we have not as yet done a free body diagram for the 10 kilogram block. So for the 10 kilogram block, we still have the force of gravity, we still have the normal force, but do we have the applied force? No, this applied force is only on the 115 kilogram, right? So what we have then is that force, which is the tension, and that tension is acting to the right. And then the other force that we will then have is the frictional force. And because it's moving, we'll call it kinetic friction. Just done that. So these two are also balanced. They give us a net vertical force of 0. So the ones that are responsible for the acceleration of the object is your horizontal forces. So what you will definitely do is to say, oh, for the net force in this case, I'm going to say it is the tension, right? As well as the kinetic friction, and that will give me MA. Remember now, I have to add them. So the tension I still do not know, so I'm substituting tension, and because it's going to the right, the tension there is going to be positive, so I will substitute it as a positive tension. Plus the frictional force is to the left, and they told us the magnitude on the 10 kilogram for the frictional force is 150, so it's negative because it's to the left, and that will give me 10A. Then my T is going to give me 10A plus 150. Now remember, my learners, the tension on the rope is the same for both the 10 kilogram as well as the 115 kilogram. The tension is the same on this rope for both of them. In other words, you can actually say this is like your equation number 1, this is your equation number 2. Then you can say the tension on the 110, right? The tension on the 115 kilogram, it's actually the same as the tension on the 10 kilogram. Now the tension on the 115 kilogram, there it is 200 minus 115A. And the tension on the 10 kilogram, it's 10A plus 150. So you need to make sure that the two tensions are both positive altogether. So it must be equal to T. It must be equal to T, not equal to a negative T equal to T. It must both be equal to T. If you do your mathematics, if you take the 150 this side and you bring it this side, it will be negative. So 200 minus 150, it will give you 50. And then that will be equal to, if you take the 115A that side, it will be positive. So it will be 10A plus 115A because they are like tens. So that will give you 125A. And then to calculate my acceleration, I'm going to say I need to divide both sides by 125. So this will be 50 divided by 125, and that is going to give us 0.4 meters per second squared. Remember, the only thing that I have now is the magnitude, and the question said the acceleration, and because acceleration is a vector, I must give both magnitude and direction, and hence I need to interpret that positive value. It means this is 0.4 meters per second squared, and the positive value simply tells us to the right. Why does it tell us to the right? Because we chose to the right as positive. Are we clear? Now, how do we allocate marks here? The first mark is for Newton's second law of motion equation. The second mark is for the correct substitution on the left-hand side for the net force. The third mark is here for the correct substitution, 10 kilogram. The next mark is for substituting correctly both the mass and the acceleration on both the 115 kilogram as well as the 10 kilogram. So that is where you get your fourth mark. Are we together? Right? Then your fifth mark, you are going to get it there on the expansion actually. So one of these expansions is going to give you a mark, expanding to us what net force actually is. That is where you actually get another mark. So that is now in a total of 5. The next mark will be for all your workings here, but finally for the 0.4 meters per second squared and also for to the right. And that is definitely going to give you your 7 marks altogether. So if you ended there, then you are going to get 6 out of 7 because you had not given us the direction, and that would make you actually lose your chances of getting a distinction. Then the last question requires us to calculate the coefficient of friction between 10 kilogram crate and the floor. So they want the coefficient of friction between the 10 kilogram and the 10 kilogram crate and the floor. Remember, we want the coefficient of friction. We don't want the magnitude of the frictional force. We want that coefficient of friction. Now, one formula that we know that has the coefficient of friction is this one, where we say the kinetic friction is actually equal to the coefficient of kinetic friction multiplied by the normal force. All together. Now we need to check because we are talking about the 10 kilogram. Do we know the kinetic friction? And we say, yes, it was given. This is what we are looking for. Do I know the value of the normal force? No, but I can calculate it. Remember now, my dear learners, we had just drawn a free body diagram for the 10 kilogram block. And we are saying these two forces, the normal force and the force of gravity, are equal. And why are we saying that? Because there is no up and down motion of our object. Now, you can't directly get the normal force. You must actually calculate the force of gravity first. And when you have the force of gravity first, then you can make a conclusion that it is equal to the normal force, right? So, what you should normally do is to get the value of that force of gravity, and you go to your formula sheet and you will find this equation. Force of gravity is equal to mass multiplied by gravitational acceleration. The mass of the object is 10. The gravitational acceleration is 9,8. And all of you know very well that this value you are going to get it from your data sheet, right? And it will give you 10 times 9,8. That should give you 98 newtons, right? Simple calculations, my dear learners. 10 multiplied by 9.8, that gives you 98. Then because you know these two forces are equal but opposite in direction, then you can actually say the normal is equal to the force of gravity. In other words, the normal is then equal to 98 newtons. Then we say, oh, now we also know the value of the normal force altogether. Then we say, oh, what is the kinetic friction? Remember, it was given from the onset. They told us the kinetic friction is 150 on the 10 kilogram. So there, I am going to substitute 150, right? And that is going to be equal to the coefficient of kinetic friction multiplied by what is the value of the normal force? 98. To get the coefficient of kinetic friction, I must divide both sides by 98. So this will be, remember, when the 98 remove this side, so divide by 98 so that they divide, also divide by 98. What we do on the right, we must also do on the left. And the kinetic coefficient, our coefficient of kinetic friction there as calculated. Just want to perform my calculation there. Okay, just getting my calculator to be on. Okay, there it's on. 150 divided by 98. And the value that we will get there is 1,53. Right, my dear learners, again, remember the coefficient of kinetic friction. It's a coefficient and it does not carry any units. So if it doesn't carry any units, it means you will just write the value as it is. And we know why it doesn't carry units, right? Because this is a force, this is a force. So you are dividing a Newton with a Newton and you will get a value of 1,53, right? So how do we actually allocate marks there? One mark is for the formula. The other mark is for the substitution for the kinetic friction. The other mark is for the substitution on the right. And the last mark is for the coefficient of kinetic. See there, 4 marks was allocated. Right, thank you very much. My calculator almost died on me, but now it's perfectly fine. So thank you very much, my dear learners.